Well, hello everyone. So it turns out this particular tool cut does not like dry cutting. Not surprised. The tool was dead anyway. The coolant was just helping it live. That was kind of exciting. Actually, this is interesting. You can see not only the huge burr that formed around the outside, but there's this heat affected zone around the outside that means that the material has actually changed a little bit, so it's probably harder. So when I put the new tool in and hit go again, it might not like it as much. It'll probably be fine, but this heat affected zone from a broken dull tool is something really to consider and to be wary of, because otherwise you're just going to trash the next tool. Exciting. Okay, so this pallet has been an evolution of awesomeness. I've been working on this thing for like 3 months. Every time I get a chance to play on it, I get to add something, like the pocket clips here. Also notice how they're on the side. I think I talked about this already a little bit. This shows the whole thing. So I get to side mill the pocket clips while they're here to remove most of the material. Then they go on here and they get their holes and they get the engraving. And then they go onto here, so they get the little Viking head, the corner round, the profile around the outside. So 3 operations just to make a pocket clip. And honestly, that's probably like the 10th iteration of how I make pocket clips. I'm happy with this method now. And then just today, I've been working on the side of the pallet. A year and a half ago, it kind of blew my mind when I was like, oh, I can put parts on the side of the fixture. That's a great idea. So we've been putting the blades on the side like that to do our bevel milling like that. So this lets our end mill come in and put in these beautiful lines using 3-axis code like that. So I made these clamps a week or 2 ago, made the cutouts on the fixture today. I have to tweak the code, make sure the code's good to be able to grind the blades on this fixture. One last thing I wanted to mention about this, which was sort of an afterthought. So I knew this was going to be heavy. It's already weighing like, I think just the aluminum was 20 pounds. And I was trying to make it lighter. So one thing I love and one thing I hate about what I did here. This is an orange style pallet, like I made the whole thing, but it goes on the orange vise. I made these significantly deeper than what the orange vices typically come with. And I love that. Like, I can hang it, I can hold it. It's super great. It just gives you so much more confidence trying to hold it. So I took that a step further and I put this channel in here, which is like a ½ inch deep, wide. You know, I'm like, there doesn't need to be any meat there, any strength or anything like that. The problem with that, combined with the fact that this whole fixture gets thinner in the middle and goes here, is that when you tighten it, it gets tightened between these 2 dovetails. Literally the whole fixture bows up like this as you tighten it, which is bad. So the cutout in this design makes it weak, and then this makes it even worse. And I actually notice like a thou or 2 of bow, which gets really bad for the parts in the middle. So once I make subsequent fixtures, which will be soon, I'm not going to put this, but I'm going to keep the deep pockets. I love that. And yeah, so once this fixture is perfect, which is super close, then I can make more, and then we can be even more efficient. Come over here, and I'll show you the old fixture. This is how we used to grind the blades on the old fixture. This is sort of like this garbage thing that I've been using for a long time. Notice how the blades are on the side. Downside to this is you have to take off that fixture, put this fixture on, change a couple things around. It's not that time consuming, but it's an extra step. Now the blades will get milled along with the handles, along with the clips. Saves time, saves downtime. Make sure you get 2 blades finished with every 2 of everything. So it's like done. So I'm looking forward to not using this anymore. And then the last step that we do is we put the blade here to engrave the serial number on it hard. And I've got a cool new solution for that, which will be in a future video. More to come on that. So this is a Norseman pocket clip, and we've had this pattern on the inside forever, for the 6-7 years we've been in business. Now I am trying some new things. I have now started mounting the clip on the side, which is awesome. And now we're left with this sweet, sweet surface. And then this will be the first clip that is now with the shiny, shiny surface. And it looks amazing, and it's awesome. Okay, over here in the lathe, that's funny. So we are making adjustable stop pins, and I'm doing a quick measurement. No, I'm too big. 6'6", I want 6'2", so I'm 4/10 too big. This machine thermally grows as it warms up. So I just go over here and I go negative 0.0035, and then just make another one. So these are the stop pins that go into the stop pin hole. We have a big one and a little one. I make them in a ton of different sizes so that we can adjust how the knife goes together. By changing the stop pin size, we can change how much lockup, basically as much as we want. So it really helps dial in the tolerances between all the different knives to make setup a lot easier. Like we used to do, they're shaving down the face of the lock bar, the end of the lock bar. And we used to do that for years. And it's just like, take it apart, cut a little bit more, put it back on, assemble. You know, we'd spend like 30 minutes dialing in every knife, and that's what you have to do until you figure out better ways, which we've done here. The other aspect is the closed position, what I like to call the detent position, and that's got to be dialed in perfect as well. So the closed position is super important for how the detent ball falls in there, how the knife feels when it's closed, if there's play, if there's springiness, how it pops out. Like, super critical, especially with our knives. We're like crazy picky with how this all works. So the main difference between the single pin versus the dual pin, okay, one pin is controlling 2 different things, the open position and the closed position. And if I make an adjustable pin, it changes both. So if I need more lockup, it also changes the detent. And if I need less detent, it changes. So it's like, it's related. So I'm like, okay, it's related. How do I separate them into 2 different things? And then I'm like, what if I had 2 stop pins? So I drew it up, and you can see the difference here in the blade. You can see on the second blade below, the stop pin stops. The top blade, the newer blade, has a much wider arc, let's call it 180 degrees, whereas the lower blade has a, I don't know, 140 degrees, whatever it is. It doesn't go as far, because this basically leaves room for a second stop pin, right? So there's that much more room in arc travel. So you can see how it works right now. The small pin controls your detent, and the large pin controls your lockup, and now they're completely separate. So if I just need to change lockup, or Eric now, because he's the one that does all the assembly, he can just choose a different size pin. He can put it together once and be like, oh, it needs a little bit more lockup, and then choose a different size pin. And same for the detent. So they're separated. So it does fluctuate a little bit, but this gives us the range and the wiggle room to like do it pretty consistently. I like it. Hopefully that is clear. These are awesome and very tricky to make, because even that one that we just finished is no good. So I'll have to go through and measure them all afterwards and throw out the bad ones. and then all the bad ones end up in here, along with all my other bad stuff. So when we install the handles on the fixture right here, we use our trusty drill to tighten it down at the exact right setting. And I've had this drill, well, here's the driver, this drill driver kit for the past 6 years or whatever. Like, our entire knife making career was set on these two drills. And just yesterday I'm using this one, and all of a sudden it just goes, and I'm like, Eric even heard it from upstairs, and he looks down, and it just died. It just froze, and I'm like, no, this is my baby. So we started using Barry's Makita drill, which is 18 volt, not 12 volt. It's heavier, it's stronger, even at a lower setting. And the weird thing is it spins down really slowly, whereas this one stops instantly. So tightening the screws with this has been causing a lot of stripping problems and everything like that. So that's what I'm actually working on right now. I'm drilling out the head of a stripped screw so that it'll chop off and then we can pull it out from the bottom. Almost done. But yeah, Amazon Prime, in 24 hours I have my new drill. Here's the old one. I briefly tried to like take it apart to see if I could you know, grease up the bearing or something, but after like 10 minutes I'm like, nope, order it on Amazon. So goodbye, old friend. Nice.
All right guys, thanks for watching another Shop Life. We have a lot of fun making these videos. Make sure to like the video and subscribe for more content. We got a lot more coming up, and we've got 2 videos, specific videos coming up, a more detailed video about our dual stop pin system, and a more detailed video about the engraving fixture that we talked about briefly in this video. It's gonna have its own kind of full-length video about how we do that. So I'm not even done with the project yet, so it's kind of this long-term thing, which I love. Later, guys.